You know, building software can feel a little bit like magic, but behind every single app on your phone, there's this incredible journey of engineering, of creativity, and honestly, constant change. Today, we're going to pull back the curtain and show you exactly how that journey unfolds, from just a simple idea into a complex living system. No, really. Just think about that for a second. That app you use to order your coffee, or check the weather, or message a friend, that started out as nothing more than an idea in someone's head. So, how did it make that huge leap from a thought into a real functional tool that you hold in your hand? Well, that's the story we're going to unpack today. All right, so first things first, let's get our terms straight. Software isn't just the code a programmer writes. It's really a complete package. Of course, you've got the instructions, the programs that tell the computer what to do. But just as important are the data structures that organize all the information. And crucially, you have the documentation that helps everyone from users to future developers understand how it all fits together. If you're missing any one of those, you've basically just got a puzzle with a bunch of missing pieces. In the discipline that wrangles all of this into existence, that's software engineering. And this definition is key. This isn't some chaotic, artistic free-for-all. It's an engineering discipline. Those words, systematic, disciplined, and quantifiable, they tell you it's all about applying proven principles to build reliable, high-quality stuff. Just like building a bridge or a skyscraper. I mean, you wouldn't want a bridge built without a plan, and you definitely don't want your banking app built that way either. So no matter which specific method a team uses, almost every project involves this core framework. You always start by communicating, right, to figure out what's needed. Then you plan the work, you create some models or designs, you actually construct the product by coding and testing it, and finally, you deploy it to the user. Keep these 5 steps in your back pocket because we're about to see them arranged in some very, very different ways. So our story starts with the first big challenge in software, this quest for order. You see, early developers were dealing with these complex, often chaotic projects that were always running over budget and over time. They desperately needed a reliable, predictable plan, a blueprint they could follow from start to finish. And the first major answer they came up with was the waterfall model. The name itself gives you this perfect mental image, doesn't it? It's a process that flows steadily downwards through a series of phases, one step at a time, just like water cascading down a waterfall. The core idea here is super simple. You complete each phase fully before you even think about moving to the next. You start by gathering all the requirements. Once those are signed off on and locked in stone, you move on to design the entire system. And once that complete design is done, you move to implementation, that's writing all the code. And only after every last line of code is written do you move to testing. It's a one-way street. In its purest form, there's no going back. So the trade-off here is pretty clear. On the one hand, this approach is simple, it's very structured, and it produces tons of documentation, which can be great for projects where you need a lot of accountability. But the downsides, well, they're significant. It's incredibly rigid. What if the customer realizes they missed a requirement? Sorry, too late. And maybe the biggest problem of all the testing happens at the very end. Discovering a major design flaw at that point is like finding a crack in the foundation of a skyscraper after the windows have been installed. It is absolutely catastrophic and unbelievably expensive to fix. So this means Waterfall isn't bad, it's a tool for a very specific job. It works beautifully when you know exactly what you need to build from day one, when the requirements are stable and unlikely to change, the technology is familiar, and the project is relatively simple. Think of building a small, well-defined accounting tool for an internal team, not, a revolutionary new social media app where user feedback is going to change everything. But as you can probably imagine, the real world rarely fits into such a perfect, rigid box. Reality strikes, needs change, mistakes are discovered, and the blueprint itself needed to evolve. This is the question that really drove the next big phase of software engineering. This is the central conflict of our story. What do you do when the world turns out to be more complicated than your initial plan? That one-way street of waterfall often leads to a dead end. A better map was needed. So the first logical evolution was a direct response to Waterfall's biggest weakness, that dreaded late-stage testing problem. The solution was the V model, an approach designed to pull testing much, much earlier into the process. The V model, which stands for verification and validation, introduces a really key change. For every single development phase, there is a corresponding testing phase happening in parallel. This means you start planning how to test the system at the exact same time you're designing it. As you're defining the high-level requirements, you're already writing the acceptance tests that will prove the final system actually meets them. The difference is pretty simple when you break it down. In Waterfall, testing is kind of an afterthought, right? It's the final hurdle to clear after all the fun, creative work is done. But in the view model, testing becomes a parallel activity, planned from the very beginning. This was a huge leap forward in quality assurance, especially for safety-critical systems. Think aerospace, automotive, or medical software, where failure is just not an option. Okay, so the V model improved quality, but it was still pretty rigid, and you still delivered the final product all at once, at the very end of a long process. This led to the next big idea. What if we didn't have to wait? What if we could deliver a working, valuable product to the customer much, much earlier and then just build on top of it? And that is the absolute core of the incremental model. You take the entire project and you just slice it into these small, manageable pieces, or increments. You build the first piece completely, design, code, test, and you deliver it. Then you build the second piece and add it to the first. Each increment delivers a functional, usable piece of software to the end user. A mobile banking app is a perfect example here. The very first increment might just be the ability to log in securely and check your balance. That's already useful. Then the next increment adds fund transfers. The one after that adds bill payments. The customer gets valuable features early on and can give feedback along the way, which is a massive advantage. The business can start getting a return on its investment sooner, and it helps steer the project in the right direction. But what if you don't even know what all the increments should be? What if the requirements are truly fuzzy and unknown at the start? Well, for projects with that much uncertainty, we need models that are designed not just to be built in pieces, but to actually evolve. The first of these is the prototyping model. Its main goal isn't to build the final product. It's to build a quick, often rough version for one single purpose: to learn. Imagine you're designing a new user interface. Instead of writing thousands of lines of perfect code, you could build a simple on-screen simulation, let real customers click through it, and then use their feedback to discover what the real requirements are before you commit to a final design. It's all about building to learn. And then we have this spiral model, which takes this evolutionary idea and adds a heavy dose of discipline. It's designed for massive, high-stakes projects. Each loop of the spiral involves planning, risk analysis, building a new version of the product, and then evaluation. That risk analysis step is what makes it so unique. At every single stage, the team is forced to ask, what is the biggest thing that could go wrong here, and how do we stop it from happening? Think about building the control software for a nuclear power plant. Managing risk is the absolute top priority. This really sums up the difference nicely. You use prototyping when your biggest risk is not knowing what the user actually wants. You use the spiral model when you know the goals, but the path to get there is full of complex technical dangers and high-stakes risks. They're both about learning as you go, but they focus on learning very different things. Now, all the models we've seen so far were really just evolutions of that original blueprint idea. They were ways to make the plan better, more flexible, or safer. But in the early 2000s, a true revolution happened. It was a fundamental shift in thinking, away from perfecting a predictive blueprint and toward creating software as a living, adaptive system. This quote, it really captures the essence of the Agile philosophy. It argues that the ultimate goals are simple: make the customer happy by solving their problem, and deliver working software to them as early and as often as you possibly can. Everything else, all the processes, the documents, the plans, is secondary to those two things. It completely recentered the entire industry on delivering value. Now, it's super important to understand that Agile is not one specific process. It's a mindset. It's a set of values. It says that while things like plans and documentation have a place, what's more valuable is collaboration between talented people, delivering software that actually works, partnering closely with your customer the whole time, and, most importantly, being able to respond to change rather than just blindly following a plan that's no longer relevant. But a mindset needs a framework to put it into action, right? And by far, the most popular framework for actually implementing the Agile philosophy is called Scrum. Scrum organizes work around these three distinct roles. You've got the product owner, who is the voice of the customer, responsible for the vision and prioritizing what gets built. Then there's the development team, a self-organizing, cross-functional group of experts who figure out how to build it. And finally, the Scrum Master, who acts as a coach or a servant leader, making sure the process runs smoothly and removing any roadblocks so the team can just focus on their work. Work in Scrum happens in these short, repeatable cycles called sprints, usually lasting 1 to 4 weeks. At the start, the team plans what they can deliver from a prioritized list called the backlog. They then work to build it, checking in with each other for 15 minutes every single day. At the end of the sprint, they demonstrate the finished working software to stakeholders in a sprint review. And finally, they hold a private sprint retrospective to ask, how can we make our process better for the next sprint? It's this relentless, continuous loop of delivery and improvement. Now, Scrum isn't the only flavor of Agile out there. There's also Extreme Programming, or XP. It shares the same Agile values, but puts a really heavy emphasis on technical excellence and specific engineering practices. For example, pair programming, where two developers work together at one computer, constantly reviewing each other's work. Or test-driven development, which is the practice of writing an automated test that fails before you write the code to make it pass. This kind of discipline ensures that quality is built into the product from the very first line of code, not just inspected at the end. So, we've talked a lot about processes, models, and frameworks, but all these systems, they're just tools. At the end of the day, they don't write code. People do. So let's talk about the most important part of this entire equation, the human element. This is the question that grounds everything we've just discussed. A process is totally useless without a skilled team to execute it. So what does it take to be part of one of these teams? Who are the people turning these abstract plans and backlogs into something real? A truly great software engineer is so much more than just a great coder. Of course, the technical skills are the foundation, but just look at the rest of this list: problem solving, adaptability, and especially communication and being a team player. Modern software is almost never built by a lone genius in a basement. It is a collaborative team sport that requires incredible communication to succeed, especially in an agile world. And those teams can be structured in a few different ways. As this chart shows, you'll see a mix of approaches out there. Some teams are highly democratic, where decisions are made by group consensus. Agile teams often lean this way. Others might follow a chief programmer model, led by a single, highly skilled technical expert who makes the key architectural calls. And of course, in many large companies, you'll still find traditional hierarchical teams. There's no single best structure. It all depends on the project, the people, and the company culture. And just look at the sheer diversity of roles on a modern team. It is not just programmers. You have QA engineers dedicated to quality, business analysts translating customer needs into technical requirements, UI/UX designers making the software intuitive and beautiful, and DevOps engineers building the automated pipelines to release it all smoothly. Building great software requires a symphony of different specialists working in perfect harmony. Which brings us to the final, ultimate question. After looking at this whole evolution, from the rigid waterfall all the way to the adaptive world of Agile, which one is actually the best? And here's the key takeaway. There is no single best way. The right process for a simple, stable government system might still be Waterfall. For a high-risk NASA probe, it's absolutely the spiral model. And for a fast-moving startup trying to find its place in the market, it's almost certainly an Agile framework like Scrum. The true mark of an expert software engineering team isn't mastering one process, but understanding the trade-offs of them all, and having the wisdom to choose the right tool for the job at hand. Thanks for tuning in.